Bright QT. Every student matters.
Hello students, let's continue our chapter Cube and Cube Roots. So in the previous section, I have told you how to get to know that a number is a perfect cube or not, right? Using the prime factorization method, and how to find out the number is cube of which number. Let's try some more practice question so that we master the topic. Just to see here, it is asking which of the following numbers are not perfect cubes. Out of these 5 parts which are given here, 216, 128, 1000, 100 and 46,656, which one of them is not a perfect cube? Let us try the method of prime factorization and find each and every part. The first part says it is 216. Let us do the prime factorization for 216. Okay, so starting with 2. What we will write? We will write 2 ones are 2, right? Now 1 is not divisible, we will write 0. And then 2 8 is a 16. Again with 2, 2 5s are 10, 2 4s are 8. Again with 2, 2 2s are 4, 2 7s are 14. Now 27 is not divisible by 2. It will be divisible by the next prime number, that is 3. 3 9s are 27, 3 3s are 9, and again with 3, 3 1s are 3. So 216 can be written as 2 into 2 into 2 into 3 into 3 into 3. Now we will try to group them in triplets, that means a group of 3 prime numbers. Here these 2's can be made a triplet, these 3's can be made a triplet. So we can write 216 is equal to 2 to the power 3 into 3 to the power 3. We know in the cube of the number, that number appears 3 times as it appears in the number, right? So here you see, yes, all the numbers, all the prime factors are grouped into triplets, so it is a perfect cube. And it is a cube of which number? Can we find out? Yes, 216 is cube of some number. That number will be calculated as, you will use this symbol. This is symbol of cube root. Okay, and we can write it as 216 like this. This you are going to learn in the next section. I am just giving you a brief of how do we write the cube root. Now what you have to do, you have to cancel the powers. Just take 2 and 3, because in the cube of that number it is occurring 3 times, but in that number it will occur just once. So 216 is a cube of 6. Is that clear? Also what we can write, just see, in case it is just asked that find out the cube of the number whose cube it is, right? So we can write 216 equal to, from this step I am writing 2 into 3 to the power whole cube, right? Why I am writing, we know a to the power m into b to the power m can be written as a into b whole power as m, right? So here it becomes 6 to the power 3. So we see that 216 is a cube of 6 and it's a perfect square. In the next lecture I'll teach you cube root also, and we're going to practice a lot of questions. Before that there are many concepts that I'm going to teach. Right now in this exercise we'll just do how to find out the cube of a number, how to find the number whose cube is given to us, right? And whether a number is a perfect cube or not. Let's move to the second part, that is 128. 128, let's start prime factorizing it. 2 6 are 12, 2 4s are 8, 2 3s are 6, 2 2s are 4, again with 2, 2 1s are 2, 2 6s are 12, 2 8s are 16, then 2 4s are 8, then 2 2s are 4, and again with 2. Clear? So 128 is written as how many times 2? 1 2 3 4 5 6 7. So I'll write 1 2 3 4 5 6 7. Let's try to form the triplets now. This is one triplet, this is another triplet. 2 is left out of the triplet. There is no triplet with this 2 that we can make. So this is not a perfect cube. We say 128 is not a perfect cube. Clear? So now let us do it for the third part, that is 1000. Okay. So third part, we have to tell whether 1000 is a perfect cube or not. Just see, start prime factorizing it. 2 5s are 10, then we have zeros. 2 2s are 4, 2 5s are 10. 2 1s are 2, 2 2s are 4, 2 5s are 10. Then with 5 we will do 5 2s are 12, 5 5s are 25. Then again with 5, and last is 5 1s are 5. So you see, 1000 can be written as 3 times 2 and 3 times 5. So we can form the triplets, right? We say it is a perfect cube. Whenever prime factors can be grouped into triplet and there is no other number left, no other prime factor left, we say that number is a perfect cube. It is a cube of which number? That will be calculated like, we can write 2 to the power 3 into 5 to the power 3, which can also be written as 2 into 5 whole power is 3. That is 10 to the power 3, and 10 to the power 3, that is 1000. Right? So this is a perfect cube, and perfect cube of which number? Of 10. Let's try to find out 100 whether it's a perfect cube or not. The fourth part is 100. Let's do it. 2 5s are 10, 0. 2 2s are 4, 2 5s are 10, and then we have 5 5s are 25. So 100 can be written as 2 cross 2 and 5 cross 5. So are we able to form even a single triplet? No, we can't form triplets in this. So we say 100 is not a perfect cube. Okay, we'll now find the last part, that is fifth part. It is 46,656. Okay, let's try to prime factorize it now. With 2 we will start. 2 2s are 4, 2 3s are 6, 2 3s are 6, 2 2s are 4, and 2 8s are 16. Again with 2, 2 1s are 2, 2 1s are 2, 2 6s are 12, 2 6s are 12, 2 4s are 8. Now again with 2, 2 5s are 10, 2 8s are 16, 2 3s are 6, 2 2s are 4. Now again with 2, 2 2s are 4, 2 9s are 18, 2 1s are 2, 2 6s are 12. Again with 2, 2 1s are 2, 2 4s are 8, 2 5s are 10, 2 8s are 16. Again with 2, 2 7s are 14, 2 2s are 4, 2, then 18 is left, 2 9s are 18. Now 729 is there. Will it be divisible by 2? Yes, it will be divisible by 3, not with 2. So 3, we write 3 2s are 6, 3 4s are 12, and 3 3s are 9. Again with 3 we can divide. 3 8s are 24, 3 1s are 3. Let's divide now 81. So you'll get 3 2s are 6 and 3 7s are 21. 3 9s are 27. 3 3s are 9 and 3 1s are 3. So we can write 4 6 6 5 6 as, how many times do we have 2? 1 2 3 4 5 6. So I'll write that 1 2 3 4 5 6. Into how many times 3 we have? 1 2 3 4 5 6 times. So 1 2 3 4 5 6. Let's now try to group them in triplets. So one triplet is this, these 3 2s. Then again this is a triplet, then this is a triplet, and this is a triplet. We see there are 4 triplets made, 2 of 2s and 2 of 3s, right? So we say that it is a perfect cube because all the prime factors are grouped into triplets. Now of which number it is a cube, we can write 2 cube into 2 cube into 3 cube into 3 cube. Okay, and we can write it as 2 into 2 into 3 into 3 whole cube. So when we multiply, just see 2 2s are 4, 4 3s are 12, 12 3s are 36. We are getting 36 to the power 3. That means 46,656 is a cube of 36. Clear? So this is how we have expressed how to, or we have done how to find out whether a number is a perfect cube or not, and of which number it is a cube, that also we have calculated. Clear? Let's move ahead now. Here is another question. They're asking, find the smallest number by which each of the following numbers must be multiplied, right, to obtain a perfect cube. So we have to search three things: smallest number, okay, and that should be multiply with that number so that it becomes a perfect cube. So let's do the first part. We have already done this kind of question. 243, start making prime factors, start doing the prime factorization. So with 2 it will not be divisible, with 3 we will start. 3 8s are 24, 3 1s are 3, 3 2s are 6, 3 7s are 21, 3 9s are 27, 3 3s are 9, and 3 1s are 3. So 243 is written as how many times? 1 2 3 4 5 times 3. 1 2 3 4 5. Let's try to form the groups into 3. Group of 3, that means triplet. So we see here this is left, right? This 3 3 is left and this is a pair. It is not a triplet, right? To make it a triplet, what should it be multiplied with? We need one more 3. So both the side we will multiply with 3. So we'll have 3 into 3 into 3 into 3 into 3 into 3. This is the extra 3 that we have multiplied. So this side we will get this one triplet, this is another triplet. So it is converted now into a perfect cube. It is 3 to the power 3 into 3 to the power 3. Now here 3 3s are 9, 3 4s are 12, 1 is the carry, 3 2s are 6 and 1 7. We get 729. So 729 can be written as 3 into 3 to the power 3, that is 9 to the power 3. So we see that 243 was not a perfect square. Then we had to find the smallest number that we can multiply with it. So what is the smallest number? It is 3. So we will write, we need to multiply 243 with 3, right? So we have multiplied it with 3. After multiplying it 3, it has become a perfect cube now, that is 729, and it's a cube of 9. Done. Let's go to another question, that is 256. In the second part we are given 256. Let's start prime factorizing it. 2 1s are 2, 2 2s are 4, 2 8s are 16. Then 2 6s are 12, 2 4s are 8. Then 2 3s are 6, 2 2s are 4. Again with 2 we'll get 16. Again with 2 we get 8. With 2 we get 4. We get again 2. And last one is 2 1s are 2. So 256 can be written as, just see how many times do we have to. 1 2 3 4 5 6 7 8 times. So 2 into 2 into 2 into 2, 4 times, 5 times, 6 times, 7 times, 8 times. We had it 8 times, right? So let us form the triplets, a group of 3 3. This is one group, this is another group. Now what is the number that we should multiply so that this 2 cross 2 always gets converted into 2 cross 2 cross 2, that means a triplet. So we are missing 1 2. We can multiply with 1 2. So we will write multiply with 2 so that 256 becomes a perfect cube, right? So it is now 256 multiplied with 2 equal to, now we have 3 triplets. One is the first one, the another one is the second one that we can see in the above one, this one, and the third one will be 2 cross 2 cross 2. This would be the third one. This is the extra 2 that we have added. Let us multiply. 2 6s are 12, 1 is a carry over here, then 2 5s are 10 and 1 11, then 1 is carry, 2 2s are 4 and 1 5, and here we get 2 to the power 3, 2 to the power 3, 2 to the power 3, that can be written as 2 cross 2 cross 2 to the power 3, that is 8 to the power 3. So we see that the 256, this number is to be multiplied with 2 so that it becomes 512, and that is a perfect cube, and it is a cube of 8. Clear? So what is the answer? What is the smallest number that should be multiplied? It is 2. Let's discuss the third part now. In the third part, we are asked about 72. Let's form the prime factors. 2 3s are 6, 2 6s are 12. Then 2 1s are 2, 2 8s are 16. 2 9s are 18. 3 3s are 9, 3 1s are 3. So 72 can be expressed as product of primes 2 cross 2 cross 2 into 3 cross 3. Let's form the triplets. Only one triplet is formed, another one is left as a pair. To make that also a triplet, what we need to multiply? Think about it. We should multiply with, yes, it is 3. So we'll multiply 72 with 3, and this side also if we multiply with 3, we already had a triplet of 2. This pair will get converted to the triplet, right? So 3 2s are 6, 3 7s are 21, right? So we are getting 2 to the power 3 into 3 to the power 3, that can be written as 2 cross 3 to the power 3, that is 6 to the power 3. So we see 216 is a perfect cube and it is a cube of 6. So what is the answer, that what should we multiply 72 with? 72 should be multiplied with 3 and it will become a perfect cube. Clear? Let's now discuss the fourth part. In the fourth part, we are given 675. So 675 we are going to try. Just to see. Let us try with 3 first. 3 2s are 6, 3 2s are 6, 3 5s are 15. Again with 3 7s are 21, 3 5s are 15. 3 2s are 6, 3 5s are 25. Then we have 5 5s are 25, right? So 675 can be written as 3 times 3 and 2 times 5. So I think now the answer is with you. What we are left with? We are left with 5 cross 5. To make it a perfect cube, we should multiply it with one more 5. So what is the answer? 675 should be multiplied with 5 so that it becomes a perfect cube. Just write them 5 cross 5 cross 5. So this is also now a triplet. This is a triplet. So you have to multiply 675 with 5. Let us multiply. 5 5s are 25. Take a carry of 2. 5 7s are 35. 35 and 2 is 37. Carry will go as 3. 5 6 are 30. 30 and 3 is 33. And here we have 3 cube and 5 cube. That can be written as 3 cross 5 whole cube. That is cube of 15. So we see that 675 is not a perfect cube. To make it a perfect cube, we need to multiply it with which number? We need to multiply it with 5 so that it becomes 3375 and it is a perfect cube of 15. Let's do the last part, that is 100. In the fifth part, we are given 100. So let's try prime factorization. 250, then dividing with 2 we get 25, then with 3, okay, with 3 what we will get? 3 it is not divisible, then with 5, 5 5s are 25, then so we get 100 as 2 cross 2 cross 5 cross 5, right? So 2 2s are 4 and 5 5s are 25. Can we make even a single triplet? We are not able to make triplet. So what should we do? To make this pair a triplet, we need to add 1 2. So I have also multiplied both the sides with 2, and here we need to multiply with 5, one more 5, right? So in the next step we will add one more 5 into it, right? Now this is a triplet, so this side also I need to multiply with 5. So what is the number that we are multiplying 100 with? It is 10. So 100 should be multiplied with 10 so that it becomes 1000 and it is a cube of 10. Is that clear? So to make 100 a perfect cube, the smallest number that it should be multiplied with is 10. Okay, let's go to the next question now. Here is next question. In this they are asking which is the smallest number by which each of the following numbers must be divided in this case. Last time what we have done? Multiplied. Now we are having a question of dividing to obtain a perfect cube. The smallest number, right, that must be divided. So what we are going to do, we will just do the prime factorization and instead of multiplication we are going to finish that factor. Okay, just see how. In the first one we have 81. So questions are really simpler. Just to see, 3 2s are 6, 3 7s are 21, 3 9s are 27, then 3 3s are 9 and 3 1, right? So 81 can be written as 4 times 3. Clear? Now there is only one triplet made. Okay, now we should think of that what is the number that we should divide both the sides so that it becomes a perfect cube. So what do we have in extra? We have this 3 as extra. So we will divide both the sides with 3. Here we have 4 times 3. Divide it by 3. You will just be left with a one triplet, that is 3 cross 3 cross 3. This one you will be left with. Let us divide it. We get 27. So here what we are getting? 27. And it's a cube of 3. So to make 81 a perfect cube, we should divide 81 with 3. The answer to the first question is 3. The smallest number by which 81 must be divided to obtain a perfect cube is 3. Clear? Let's move to the next part, that is 128. Okay, 128, let's prime factorize it. 2 6s are 12, 2 4s are 8, then 2 3s are 2 2s are 4, 2 1s are 2 6s are 2 8s are 16, 2 4s are 8, 2 2s are 4, and 2 1s are 2. So 128 is written as how many times 2? Let us see. 1 2 3 4 5 6 7. Count them again. 1 2 3 4 5 6 7. So 2 into 2 into 2 into 2. 4 times, 5 times, 6 times, 7 times. Let us try to group them into triplets. This is one triplet. This is another triplet. So 1 2 is left extra. Now what should we divide 128 with so that it becomes a perfect cube? It should be divided with 2. So divide it by 2 this side, and here you will have 2 cross 2 cross 2 into 2 cross 2 cross 2 into 2. When it is getting divided by 2, it will get cancelled up. We are left with 2 cube into 2 cube. Dividing here, 2 6s are 2 4s are, we get 64. So 64 is equal to 2 into 2 to the power 3, that is 4 to the power 3. Now we observe here that the smallest number that should be divided, that should be there in division with 128 so that it becomes a perfect cube is 2. So 2 is the smallest number that 128 is divided, and it got converted to 64. 64 is a perfect cube of 4, as you all can see. Right? Let's do the third part. In the third part, what we have? We have 135. So it is not divisible by 2. The next prime number is 3. Let's try with 3. 3 4s are 12. Then 1 is left. 3 5s are 15. 3 1s are 3. 3 5s are 15. Again 3 5s are 15 and 5 1s are 5. So 135 is written as 3 times 3 and 1 time 5. Forming the triplet, what is the extra number left now? 5. So we will divide both the sides with 5. So that we are left with only 3 cross 3 cross 3. Right? So 5 and 5 got cancelled, and here 5 1s are. Here what we will write, if we divide 135 with 5 2s are 10, 3 is left, 5 7s are 35. We are left here with 27, and here 3 to the power 3. 3, this is what we are left with. So we say that 135 should be divided with 5 so that it becomes a perfect cube, and it becomes 27, which is a perfect cube of 3. So what is the smallest number that 135 should be divided? It is 5. At the end of the answer, you can just write like this. Therefore, 135 must be divided with 5 to make it a perfect cube. Right? Like this you can write your answers. Let's discuss the fourth part, that is 192. 192. Let's divide it. So starting with 2. 2 9s are 18. 2 6s are 12. 2 4s are 8. 2 8s are 16. 2 2s are 4. 2 4s are 8. 2 1s are 2 2s are. Then we have 2 6s are 12, 2 3s are 6, and then we are left with 3. So 192 can be expressed as 1 2 3 4 5 6. 6 times 2, 1 2 3 4 5 6, and 1 time 3. Now if we form the triplet, these two are forming the triplet. These are the two triplets. Now 3 is extra left. So what should we do? We should divide both the sides with 3. So 192 should be divided with 3. So 3 is the smallest number that 192 should be divided so that it becomes a perfect square. And this side we have 2 cube and 2 cube left because this 3 would cancel out when we divide. So when we divide we get, let us divide 192 with 3. So with 3 6 are 18, right, and 3 4s are 12. We get 64, and here we will get 2 cross 2 to the power 3, that is 4 to the power 3, cube of 4. So we see that 192 should be divided with 3 so that it becomes a perfect cube, and it becomes 64. 64 is a perfect cube for 4. Clear? Let's do the last part now. Fifth part, we are asked about 704. Let's do the prime factorization. Starting with 2, we will write 2 3s are 6, 2 5s are 10, 2 2s are 4. Right? 2 3s are 6, 2 5s are 10, 2 2s are 4. Again with 2, 2 1s are 2, 2 7s are 14, 2 6s are 12. Again with 2, 2 8s are 16, 2 8s are 16. Then you get 44, then you get 22, then you get 11, and 11 is divisible by 11. So 704 can be written as 1, 2, 3, 4, 5, 6. 6 times 2. 1, 2, 3, 4, 5, 6. Right? So these are going to form the triplets. And what we are left with, one more, 11. So 11 is the extra number. We'll divide 704 with 11. Divide both the sides with 11. So we will get 2 to the power 3 and 2 to the power 3 here because 11 will get cancelled up. So 11 ones are 11. Here 11 6 are 66. 4 is left. 11 4s are 64. So we will be left with 64, and here it can be written as 2 cross 2 to the power 3, that is 4 to the power 3. So we see 64 is a perfect cube and it is a cube of 4. So 704 should be divided with what number? 704 should be divided with 11. So 11 is the smallest number by which 704 should be divided so that it becomes a perfect square. Clear? Let's move ahead with the next question. So here is one question. They're asking, Parikshit makes a cuboid of plasticine of sides 5 cm, 2 cm and 5 cm. They're asking how many such cuboids will he need to form a cube. Right? How many such cuboids does he need for forming one cube? So this is one of the questions that we discussed. It is similar to that. So try to recall what we have done. So now, what is volume of cuboid? Volume of cuboid will be 5 cross 2 cross 5. Okay, so this is what is volume of cuboid. Length into breadth into height we have done. We are asking that these numbers should make a perfect cube. So to make a perfect cube, just to see, we have 5 cross 5 and we have 2 extra. Okay, so to make this as a triplet, what we are missing? We are missing one 5. So here we'll multiply with one more 5. This is the additional 5 that we have added, and here 2 is alone. To make it a triplet, we need to multiply 2 more 2's like this. So this is extra we have added. So now it is a cube, it is a like making a triplet, and it is making a triplet, right? So what we are adding actually 5 and 2 into 2. So we are multiplying 5 into 2 into 2, and it becomes 5 into 2 is 10, 10 into 2 is 20. So 20 extra we are multiplying. Just see, after multiplying what we get? We get 5 5s are 25, 25 into 5. How much we get? We get it as 125 into 2 2s are 4, 4 2s are 8. Let us multiply it. 8 5s are 40. Carry is 4. Let's multiply it here. It would be easy to observe. 8 5s are 40. 4 is the carry over here. 8 2s are 16 and 4 20. So 2 is a carry. 8 1s are 8 and 2 10. So we get 1000. Right? And that means what is the extra thing that you have multiplied it in? 20 is the extra thing to make it a perfect cube, because now see, it is a cube of side 10 centimeter, 10 into 10 into 10. So from cuboid, if you have to form a cube that has equal dimensions, what you need to do? You need to write the volume, and after that try to make the triplets. Whatever is missing, just add them. So one 5 was missing and 2 2's were missing. So we have added them. That means how many How many such cuboids will he need to form a cube? He needs 20 cuboids. The answer is 20 cuboids to form a cube, and it will have the dimension as 10 into 10 into 10. Length is 10, breadth is 10, and height is 10. As you know, in cube all the dimensions are equal. So what we have discussed, that how to check whether a number is a perfect cube or not, of which number it is a cube, right? What is to be multiplied to form it a perfect square, what is to be divided to form it a perfect square, and questions like this, that how many cuboids you will need to form a cube. Clear? So whatever dimensions are given, just follow this method. You're going to find out number of cuboids that require to form a cube. I hope this gives you clear idea about the concept.